Okay, so in this session, let's talk about the curve fitting, right? Okay, I didn't read the title, curve fitting. Okay, so when we talk of curve fitting, we are simply talking about a process of finding a mathematical function in an analytical form that best fits a data set. So we are simply trying to, we have a particular data set, and then we are trying to get a graph that represents the data set. Okay, so they've given you a set of points. Let's just, so they've given you a data point, like some points, like maybe say a, maybe 2 3, it's a data set anyway, 4 5, anything, like in that order. You get what I mean? So you have this set of data points, and then you are trying to draw a particular graph that best describes all of this, maybe not to totality like in idealism, but then to some extent describes these data sets. Okay, so you can do curve fitting by constructing a curve, right? So on the graph you can just construct a line that moves through most of them, or you can find a mathematical function which will be a best approximation of the function. So that's what we are going to be doing here. So we are going to find mathematical functions to approximate some data sets. Okay, so let's get to more early. So here, for instance, you have 2 points. Okay, let's call this point 5 5. Okay, and we have this point, say 0 1. Okay. Oh. Okay, sorry. So they're supposed to be like 0 1 5 5. You have these points, and then you are trying to fit these. Then you can simply draw a straight line that moves through both of them. Now in this case you just have this and that, so you can simply find the equation that best describes them by using something like this, right? So you need just your gradient, or to make it more easier, alright, you can just say I'm into bracket x minus x1, something like this. So you can use this formula too. So you can find your gradient, your difference in y over difference in x, right? Then um, then you would get your the gradient of this function, right? So you can simply say, okay, then y equals something, and then that describes this. That's curve fitting. So that means we fit this data. Now let's look at another scenario where we have something like this. So with the previous one, I wasn't necessarily finding the equation of the graph, right? Just to illustrate how it works. Now something like this too. This is an illustration anyway. This is the x-axis, and then this is the y-axis. So you have a set of points. So you have 1 2 3, and then that's labeling. So you have one. So this point should be probably 1 1. Here we have 2 4. Here we have 3 9. Okay, so if you have a set of points like this, and then you are being asked to fit these, as in what equation will best describe these, then you'd have to yes, so this is a polynomial, right? Then you have to find ways to find the equation of this. Now from what we already know, we know that if a point pass, if a line passes through here, passes through here, passes through, now we don't have more points, just 3, so we can just say, okay, then this thing will look like y equals x squared, right? Just presumably. If there are other points, then we can debate on that. So over here we have 1 1, which works. If this is 2, this is 4, if this is 3, this is 9. So something like this describes it. So that's curve fitting. We've simply fit the curve, right? Or we fit the data point onto a curve. So that's all about curve fitting. And then we can use this knowledge to find other points on the line that most likely um, relate to the data we have. Yeah, so that's basically everything about curve fitting, an overview. Okay, now there are many forms of curve fitting, but then what we are simply going to do, or what we've done in class, that's the least square regression, right? Okay, okay, let's also get something like this. Now let's say we have a particular data. I don't know if you can see this clearly, but all the dots here are data points. Okay, now you want to fit these data points onto a particular curve. So which of these lines best represents the data? That's just an open question. You can answer that for yourself. But then you see that you are trying to estimate a particular like some good curve for all the data. That's all about curve fitting. Okay. So let's talk about the least square regression. So if we talk about least square regression, like the name implies, so we are trying to, yeah, and then this best relates to the regression that was done in high school, right? High school regression is very related. But then what we are trying to do here is that with this regression model, we are trying to work on reducing the errors, right? So we are talking about the least square error regression, so something like that. So if we talk about the error between a particular function, so let's say if we have a particular function like this, and then this same thing is probably an estimate. So one of them is an estimate, one of them is the real one. So let's say if this is the real one and this is the estimate, then the error will be the difference in these two. So let's say I say y equals, this is just some assumption, okay, y equals 1 plus x, okay, and then from my estimations I estimated that y equals 0.9 plus x, okay. Now you can find the error between these two by doing a simple difference. That's what I just mean by the error between the main function and then an estimate. So with what least square regression is trying to do is that it's trying to minimize the square of the error. Then that means that we are talking about this square. Okay, so then error squared as that. Okay, so let's get here. So the least square method seeks to minimize e squared, that's the error squared. Then we have this. Now since it's a squared, alright, then it doesn't matter which one comes first. The directionality does not matter because they will simply cancel out. Okay, so let's okay, so types of the least square regression methods we have linear least square regression method, multiple linear. So we have the multiple linear, it's not multiple linear least square regression. That's very bad. Yeah, and we have the non-linear least square regression. So with the non-linear, we're talking about polynomials and other forms of functions, cubic, all of those are polynomials anyway. But then those are non-linear. So let's solve, or let's better understand what the linear least square regression method is. Okay, so let's take it step by step. Okay, so let's say we have, so from the example we made, something like this. For all linear graphs, right, all linear graphs can be explained with something like this. If it's linear, once they tell you it's linear, then something like this can explain it. So y equals ms plus c, that means it's just a straight line. Now let's say we have a function which is y equals ax plus b, which is not different from that, right? And then we have some estimate somewhere, so either this is the estimate or this is the real, it still works. Now we want to find the difference between these two. Okay, so you can simply say this minus that, so y minus f of x, then that can simply be ax plus b minus f of x, or vice versa works. So if this one is the ax plus b, then you can say here ax plus b, or you can say ax plus b minus y. So each of them works. Okay, so let's just get to here, then let me try to explain this. Okay, so here we have some function which is a function of a and b. Okay, so if we are going to do the least square regression for linear data, then we are going to take, okay, so the a plus bx is the same thing. A plus b is the same thing as say bx plus a, right? It still looks like mx plus c minus yi. So we are trying to do a summation. We are adding a particular set of points. Since we have a data set, then we are taking the square of that. So that's why you have from a particular, so from the first one to the last one, which is an n, in that order. So let's talk about the necessary conditions, right? But then before you solve any curve fitting question, right? There are some things you need to have, right? You need, let me just show you this. So you need a tabulated data or a data set. So number one, let me just give you the three things. You need a data set. Tabulated is, for our application, tabulated is better, right? You need the form of the function. So here, that's what we're working on. We told you that it's linear, okay? And you need a criteria, curve fitting criteria. So we say curve fitting criteria, just like a blueprint for the curve fitting. So we'll see more about that when we continue. Okay. So this is, so for a necessary condition, right? This is a necessary condition for curve fitting. Now the partial differential of the function with respect to any one of the points should be 0. It's a necessary condition for the thing to work. Now you can think of why it is necessary, right? What does it mean if a partial differential with respect to a particular variable or one of the variables in a function is 0? What does it mean, right? Why does the partial differential with respect, so how it is changing, how the whole function is changing with respect to just a should be 0, and then why the whole function is changing with respect to b should just be 0, right? Because we are talking about a linear graph here. This is linear, right? So that's just it. Okay, so let's get to a particular form here. So we have a equals, we have a plus bx minus yi. So you can see this whole thing as some f of x. Okay, so this is an error. Okay, so we can have y equals a plus bx, and then that also gives us a line. So these things are simply the same thing. Now what we are going to do is that if they give you the question, how do you generate the equations to solve the function? Okay, so they'll give you a data set, and then you would have a criteria, or they'll give you a form of the function, something like that. So how do you generate the equations you need, especially for your data sets? Okay, so let me just take you through how to derive the formulas. Okay, so here, so you have this y equals a plus bx. Now for your first formula, let's just reproduce the question we have. We're just reproducing it. So we have, try and see it this way. Now this is the only thing you find different here, the n. So we have n plus summation xib equals some summation of yi. Now you have this summations because you are dealing with a set of data, right? A data set. So you are not just dealing with one point, you are dealing with 2, 3, 4 or more. Okay, so since each of them is a summation, right, then it makes sense that we multiply the number of data sets or the number of data points you are working with by the first one, right? So this is your first equation. You have your number of data sets or number of data points plus the summation of xib, right? You can always write the limit equal to the summation of yi. As simple as that. Okay, now you need two equations. Okay, you need two equations to find the equation of, okay, so let's say you need some point, right? You need two equations to find two unknowns as that. So you have a, which is an unknown, you have b, which is unknown. So you can't find two unknowns with one equation. It's practically impossible. So to find that, you have to find another equation. So we have to find an equation 2. We can simply do that by manipulating the data a little bit. So this is what we do. We just pick, so over here, this is the variable we are working with. We are working in x. So you just take x and multiply through. I hope you got that. So just take x and multiply through. So here we have xi times a. So summation of xi times a plus summation of xi squared, because you are multiplying 2. So summation of, this will be 2 now. So summation of xi times another xi, then you have summation of xi squared times b all times the summation of xi yi. Okay, so let's maybe with um these, they might look a little scary, but then let's just make it simpler. Okay, so let's just pick a data point, right? Some data set. So if we pick some data like this, okay, so let's see how we can generate the equations that will give us a function to better describe this. So let's say they give us the form of this function. Pick a sheet. Okay, so let's say they give us the form of this function to be y equals a plus bx. Okay, then we have to find the first equation. So we say the first equation will be na plus summation of xi b, right, equal to summation of yi. This is equation 1. Now for equation 2, multiply the xi through. So we have summation of xi a plus, there are going to be 2 now, so summation of xi squared b plus summation of xi yi. Okay, now, okay, so here, what's our n? From this first data, from this one, our n is just 1, 2, 3. So our n will be 3 for this data. And then our xi, so summation of xi. Now this is where you have to really be careful with the data you're working with and how you punch things into your calculator, because you can simply just get off the line. So here you have summation of xi. What is summation of xi? That's summation of values in the x domain. So this plus this plus that. Cool. So 1 plus 2 plus 3, that will give you 6. So our first equation, we say, so 3a plus 6b equal to summation of yi. What summation of yi? We have 5.1 plus 5.9, which gives us 11, right? Plus 6.3, which gives us 17.3. Okay, now this is equation 1. Now you know that you cannot find a and b with just equation 1, so we need to find another equation. That's where this one comes in. So here, let's do the next one. So we say xia, so summation of xi. What summation of xi? That gives us 6. So 1 plus 2 plus that, that's 6. So 6a plus, and we do the next one, summation of xi squared b. Now here, you don't take 1 plus 2 plus 3 and you square everything. So you don't take 6 squared, that'd be wrong. So you say 1 squared plus 2 squared plus 3 squared. Let me repeat that. So when we say summation of xi squared, so xi squared, so we don't say summation of xi all squared, right? These are different. So let me just show you this. So summation of xi squared and then summation of xi squared, these are different things. So summation of xi squared, this means that you just add the xi's and you square them. So if it were for this data, that would be 36. But then summation of si squared means that you sum the squares of each of the individual x values. So let's do that. You can decide to do this in a table, but then I don't like using the tables, right, for this particular this one, because the tables would be like a little bulky. So here we do, but then if you prefer the tables, that's equally fine. So that would be 1 squared plus 2 squared plus 3 squared, right? So 9, 14, so that gives us 14b. So summation of xiyi. So over here, that would be summation of this time this plus this time this plus this time this. Okay, so xiyi, so we say 5.1 plus 2 times 5.9 plus 3 times 6.3, and then we have 35.8. Now at this stage, you can decide to solve it anyhow you want. So you have 2 equations, you can solve them with any method that is convenient for you. You can decide to put them into the calculator. It's going to be OBJ, right? So you can simply go to your calculator and then you go for 5 equations, and then for simultaneous equations you can just go for 1. Okay, now we can just enter our details. So 3, 6, and then 17.3. No need to make it negative. We have 6, 14, and 35.8. Okay, and let's put an equal to. So you get your x, which is an a. So you get a to be 4.5666. So let's just put a 7 there, and the b to be 0.6. Okay, so now you are not done. You are going to do your curve fitting now, right? You are going to conclude on your curve fitting. So they told you that the function had a form like this, and now you have found a and b, so you can now tell them that, okay, more accurately, the function is 4.6, I'm just approximating, plus 0.6 x. So that means that if I have another term, another x value, right? So let's say we want to predict what will be the value of the function when x is like say 4, then we can simply say y equals 4.6 plus 0.6 times 4, and then that gives us a new value. So here we have like 2.4, we add that here, then we can get that 7, right? So that's simply how you solve it. But then you realize that when you check in the slides, you see something different. Let me show you this. It's not really different, but then it can be a little confusing. So you see all of these, and then it might be a little tricky. So yeah, so this is simply what we're doing. Honestly, you don't need to do this. It's not really important. So you don't need to make b the subject. You don't need to make a the subject. You can simply solve and then finally get your values, right? Now let's pick. So you can solve this example when you are free, right? So 4, 5, 6, 7, and then so you use the same criteria or the same blueprint for generating the equations for the two. Yeah, so that's just for linear. Now let's move on to a more complex form, which is the multilinear regression. Okay, so with multilinear regression, they'll give you a function or a form of the function, right? Something like this, and then you have to use the same methods we discussed to generate equations for the three, and then solve those three equations to get your a, b, and c. As simple as that. So I'm just going to show you how to generate these equations again. Okay, so here, but then you know that we are using the least square regression, so definitely you have a difference, square of the difference. Yeah, so these are just basic requirements you have to do. If it were theory, you need to do all of these, right? But then since it's not theory, it's not so important. Now let's generate the equations. So let's say they give you y equals a plus bx plus ct. Okay, now something like this to generate the two equations. So you start, so here a plus summation of xib plus summation of tic equals summation of yi. Now because you are dealing with a number of points, okay, we don't know the number of points, you can just put n here. So n a summation of xi, this is a particular number. Yeah, when you're doing it, if it were theory, this would have been very important, what I mostly neglect from. So if it were theory, you really need to do all of this, right? But since it's not, I'm just skipping some of the things. So this will be your first equation. Now to generate, now let me ask you this question. You have three variables, you have three unknowns, you have a, b, and c. Now how do you find three unknowns from one equation? That is totally impossible. From two equations, still impossible. From three equations, yes, you can do that. Yeah, so you need three equations to find three unknowns. Yeah, in the context of this. Okay, so let's so now let's do the next one. So to do the next one, you just take the coefficient of the b, multiply it through. So you have the summation of xi a plus summation of xi squared b plus summation of xi tic equal to summation of xi yi. So this is equation 1, equation 2. Are you seeing that? Equation 2. Now to generate your equation 3, now you come here, pick the coefficient of this and multiply through. So you see summation of TIA plus summation of TIXIB plus summation of TI squared equals summation of TIYI. Okay, so let me go over the whole process again. So to generate your first equation, you have NA plus everything else, right? So summation of XIB plus summation of TIC equals summation of YI. For a second equation, you have to multiply this by each of the terms. So this is the base, this is your base equation. So you just take this and multiply through. So but then over here, since we are now dealing with the exact number, the n will not come. So you have XIA plus XI squared, because you are multiplying by itself, that will be squared. Multiply by here, that will look like this. Multiply it here, and then your TI, right? Then for the third one, you now take this one and multiply through here. That's okay. Yeah, I hope you got that. Now let's see if we can have an example to illustrate this. Yeah, so these are the same formulas we generated a while ago. So if you have these, right? So let's see how we go about the first one. So for the first one, let me just draw that. Okay. So let's get the first one down. So we have how many? 1, 2, 3, 4. So we have 4 sets of data. Okay. So we are going to say 4a plus summation of xi. That will be this plus that plus that plus that. Okay. So you have basically 0.9. 0.9b plus summation of the ti times the c. So where's the ti? This plus this plus this plus that gives us 6c, or equals the summation of y. So this plus that plus that, that gives us 8. Okay, so this would be our equation 1. Now we need 3 equations, so let's generate the next two. So here, okay, let me bring that here. Okay, so this is going to be our equation 2 from here. So summation of xi, alright, that will be this plus that, that will be 0.9. So 0.9a plus summation of xi squared, right? Okay, so you have to be careful. So you don't say 0.9 squared, you say 0.1 squared plus 0.4 squared plus 0.2 squared plus 0.2 squared. Okay, so let me get this off. Just clear my calculator then. So we have 0.1 squared plus 0.4 squared plus 0.2 squared plus 0.2 squared. Okay. Okay, there's something there. Okay, so we have this. So this gives us 0.25. So we have 0.25b plus here, right? So over here, over here. So you have xiti. So this time this plus, this time this plus, this time this plus, this time this. Okay. So this one gives us 0.4, another 0.4, that's 0.8, 0.6. So 0.6 plus 0.8, that gives us 1.4. So 1.4c. Then that equals xiyi. So that's this time this plus this time this plus this time this plus this time this. So let's do that. So 0.3 plus 0.8, 1.1 plus 0.2, 1.3 plus 0.4, that gives us 1.7. Okay, so this is so this is your equation 2. Okay, so this is your equation 2. Now you need your last equation, that will be your equation 3. So to generate your last equation, let me get that for you. Okay, so to generate your last equation, you have summation of TIA. So summation of TI times A, that's 6, right? 6 times A plus your, okay, I think I misplaced it. So SITI Okay, so xiti, I think we've done that already. That was somewhere around. Okay, let's do that. So xiti was 1.4. I think I remember. So that was 1.4. Okay, so go 1.4b plus summation of ti squared. So what's a ti? 0 squared plus 1 squared plus 2 squared plus 3 squared. So 3 is 9. So this is 14. 14c equals summation of tiyi. So this time this plus, this time this plus, this time this plus, this time this. Okay. So we have 2, 2, 4, 6. So 4 plus 6, that gives us 10. So basically we are done with our 3 equations. So now when you have 1, 2, 3, when you have 3 equations, you can simply move to your calculator, no time to waste. It's going to be obj and then you don't have so much time. So you can just go to mode 5 and then to solve 3 by 3 simultaneous equations, use the second one. Okay. Yeah. So this, and then you input in your values. Okay. So when you do your value, like when you input your values, let me get this for you. Okay. So you can solve this quite later. So just like the same way, you put in 4 here, 0.9 here, in that order. Alright, seems the video is getting so long. Yeah, so when you put everything inside, these are just simultaneous equations. You end up with your a to be 2.9574, b to be negative 1.7021, and then your c to be negative 0.38298. Okay. So with this information, you can now see that okay, your y equals a, which is 2.9574, plus bx plus so that will be negative. So plus negative 1.7021 x plus c. I did it again. Plus negative 0.38 blah 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 c. So this is going to be your final equation. So this is curve fitting, right? So this equation is what best describes this data. And then if they give you any value of t and x, you can estimate a particular value of y. So let's say there are two scenarios, right? Some t somewhere, some x somewhere. Then when you fix them back into the equation, then you should get a corresponding y. And then yeah, so that means you always need 2 points to solve this. Okay. Let's move to the last one. That is going to be the nonlinear regressions, right? So nonlinear regression can come in many forms. Okay. Yeah. So with nonlinear regression, it can be anything. It can be cos, sine. That's trigonometry actually. It can be it can be some other function somewhere. It's really differs. And then the method for finding the 3 equations or 4 equations or what a number of equations you need to solve the nonlinear regression is practically the same method, but then this something might be a little tricky here. Now we've done this, okay, we've done forms like this. So here to generate the 3 equations, you simply take so let me just take you through that. So f of x, so you know the difference and everything. So here let's say na plus summation of xib plus summation of xi squared c equals some summation of yi. Okay, so now to find your next equation, you just multiply your summation of xi through. So summation of xi a plus summation of xi squared b plus summation of xi cube. Okay, c equals summation of xi yi, and then your third equation will be summation of xi squared a. We are just multiplying this one through, plus summation of xi squared b plus summation of xi power 4 c equals summation of xi squared and then that. Okay, yeah. So over here, yeah, so with these ones you just have to do substitution and then solve the rest, right? So But then let me just show you how to do when you have something like that, and then I'll see if we have any example to solve. Okay, so we say f of x equals a ln x plus b cos x plus ce or x. Now if you have something like this, realize that this deviates a little from what we've been having, because everything we had initially had no coefficients for the coefficient of a was just 1. Okay, but then here we have a ln x attached. So how do we generate the three equations? So your first equation, you have to simply multiply this through. So let's do that. So summation of the ln x, right, whatever x that ln x a, plus summation of ln x cos xb plus summation of ln x exc equal to summation of ln xy, sorry, and then we come here. So you see I just multiplied the ln x through. Right, now let's get to the next one. So we have cos, so we can have summation of, okay, sorry, so here becomes a squared because there was ln x already, so that order. The next one is a cos, so we say ln x cos x, right, a plus summation of, we have cos again, so cos squared of, so yeah, so cos x squared, right, this can be a little different, okay, yeah, of b plus your summation of ex cos x equal to summation of cos x y I, right. Now if you are solving in theory to be really different, right, you can't do some of these abbreviations, okay. I've stated that already. So this equation 2, so 1 2. Now your equation 3, just multiply this one through. So we have our equation 3 here. We say summation of e x ln x a plus summation of ex cos x b plus summation of ex squared. Right, you can put the 2 anywhere, doesn't really matter, and then equal to summation of ex yi. Okay, now with these you can now do your summations and then put them inside. Now let me see if I can get an example so that we, okay, so I got some data here, right? So we have some x y to be this data, and then they've given us the form of the function to be a ln x plus b cos x plus c e x. Okay, so something like this. You've generated the three equations, you know they're ready, right? These, and then you have this, right? So let's get to equation 1. So equation 1 will be so ln x squared, right? So 0, so let me just show you how that will be done. It might look a little tricky, right? Okay, so what happens here is that you just take so you do ln of your first value 0.24 squared plus ln of the second one plus ln of the third one, in that order. So like, right, so when you're done, you just keep summing, right? So you sum all of these, that will give you some particular value. Okay, so when you do that, well, let me just get you the values so that when you're working, so for a particular data like this, you might want to draw a table, right? You might want to draw a table that's, yeah, so because there are many, right, you might want to draw a table that contains the major things you need here. Okay, so you have your xi yi on the table, you have your, so you need your ln x squared, okay, something like this, and you need your ln s cos x, right, something like this. you need your ln x ex. You might need your, okay, something like this, ln x cos x. We have that. Okay, you might need your ln x y I. You might need your cos x squared. Okay, of cos x ex, cos x yi, and then ex squared, and then exyi. So you can imagine how these things are just so many. So with this particular questions like this, you have to really take your time to solve them. Yeah. Okay, so you can put them there and then you keep doing that, right? So 0.65, I'll just pick a few of them. I won't use everything from here, so that we just see how we can go about with all of them, right? Okay, let me just pick these two, then we do the summation, right? So here, if you pick and then for the y's, pick the y's to negative 0.23 to negative 1.1, and then yeah, and then the summation. That's fine. So here we have a ln of 0. So here you have ln of 0.65 squared, a particular value, right? And then you have ln of 0.95 squared. Then when you're done, you add these two, right? So you just add them, you put the value here, then you do the same thing for everything. So when you check in the slide, that's about like 43 there about. And that's what he has done in the table. It's a little messy, but then that's just it. So from the values you get, right? So from the values you get, you can, so these are the three equations he ended up with. And then when you end up with equations like this, you can simply put them into your calculator and get your three values. So you can see here is a to be that, that, and that. And you can just simply put them back into the equation. This is like the simplest step. So you simply put them back into the equation and then you have your answer, right? So that's simply everything about curve fitting. Yeah, so we've discussed the linear curve fitting, right? So we've discussed linear, we've discussed non-linear, right? And then multilinear, right? Multilinear or multiple linear, right? Yeah. So these are just like the three methods for least square regression, right? So if you don't understand anything, you can always put the question in the groups. I'm sure someone will answer you. Thank you.